So coming to our application, Cyborg network, so there are two core features. So one is worker registration and the second is task scheduling. So in this demo, I'm going to walk you through both the functionalities. So first, see the worker registration. So this action is performed by the data centers, which are providers, compute providers, storage providers. So first, let's explore these actions. So we have contracts deployed already. So first, let's create register a worker. So now this particular worker has 200 GB memory and 12 CPU cores and 500 GB storage. So let's register this also. Okay, so that was successfully registered. Now let's try scheduling a task. So I've recently submitted a task with this Docker image. Let's resubmit it again. Okay, so I'm trying to schedule an execution deployment with this Docker image. So now when I press transact, what's going to happen is so there's a new there'll be a new deployment in the Kubernetes cluster. So with this image, with this particular image, so we'll see how it goes. So I've just executed it. Okay. So we can see chain a function has been triggered in the Dawn network. The request ID is 059, which has been just triggered. So as we can see that the computation and callback has been done. The smart contract has been updated with the fulfill task. So let's see what's the output of computation. Oh, okay. So the deployment and service has been created. Let's see if this deployment has been really created in the backend. So this is my backend where we can check the deployment status. As you can see, the deployment has been scheduled on one of my Kubernetes server, and this happened just a few minutes ago. I'm sorry, I had to cut off the video because I'm waiting for the transaction to get confirmed. So I have one master and one worker deployed for this demo. So which is why you can see there's one replica. Okay, so as we can see, the deployment has been successfully created with this deployment name. So let's see the code. Let's walk through the code once. So that deployment has been created because of this function, schedule tasks, since we triggered this function. So here we are randomly selecting a public address, provider's public address, and then we are calling the oracle with this information, which is Docker image, and then the public address of the provider, and the task ID. So as we can see here in the send request, so we have source code already defined here. So so this is called chain link function. So where the actual Kubernetes deployment and decryption of the secrets, everything is happening in this function. So first we are setting up that source code, and then so this Dawn hosted secrets. So we have a couple of secrets. So one is encryption key, and then the second one is backend server IP address. So both has to be secretly maintained. So that's why we have hosted these in the Dawn hosted secrets. So we are submitting this function to the Dawn network for executing. So just let's export that function. So this is that function that I'm talking about. So the static queue. So what should happen in this is, so it should actually get the encryption key and then fetch the data from the IPFS. So data as in, I mean the encryption mapping of public address of the provider and his IP address. But then there are certain limitations in the chain link function, so which is why we cannot achieve the decryption part in this function. So that's why what we have done is we had a backup backend server actually. So we have stored the IP address of the backend server in the Dawn network to maintain the secrecy of it. So that's why we are fetching in the chain link function, and then we're passing the public key of the provider. So where, as you can see, as you can see, we have selected the public address of the random worker using VRF. So we send that public address of the provider to the backend, and we get the decrypted IP address. See, using that IP address, we initiate the compute by passing the Docker image. So where the final deployment happens. So this is how it's done. Yeah. So, but we'll explore the decryption, how we can achieve the decryption inside the chaining function, so that we can avoid the secondary backend server where the actual decryption is taking place right now. That's it for the demo, guys. We tried our best to integrate the entire backend functionality with the front end, but due to the last minute hiccups, we could not do that. So that's why I'm here explaining the backend functionality. Anyway, we tried to upload a video of our application functionality. Please to review it and also check this one, the backend functionality especially. Thank you for your time.